In this video, we will find the tangent plane to the graph of a function of two variables. So in this example, here's our function, square root of y times e to the 2x. We'll call that f of x and y. And the fact that this point is on the graph simply means that if I plug in the first two coordinates for x and y, I get the third one as the function value. So, let's recall that in general, the tangent plane at the point where x and y are equal to a and b is given by this formula. Z minus the function value at that point is equal to the partial derivative with respect to x at that point times x minus a plus a similar term for y, the partial derivative with respect to y at the point ab times y minus b. So we just want to apply this to our specific case. So we need to just compute the partial derivatives and plug everything into this formula. So let's do that. So the partial derivative of f with respect to x is the square root of y is just a constant when we're differentiating with respect to x. So we're just taking the derivative of e to the 2x, which is 2 e to the 2x. Okay, now the partial derivative with respect to y. Now e to the 2x is a constant, and y is the variable. And the derivative of square root of y is 1 over 2 times the square root of y. Okay, but we need to plug in our particular point into these partial derivatives. In our case, the point AB is the point 0, 1. So what we need is fx at 0, 1 and fy at 0, 1. So let's do that. If x is 0, then we have e to the 0, which is just 1. And the square root of 1 is 1, so this is just 2. And this is 1/2. And now we have everything we need. So let's just plug it all in. So, the tangent plane equation is z minus f of ab, as we noted at the very beginning, is 1. Fx at 0, 1, we just computed was 2, times x minus a. Here a is 0, so we just have x minus 0, plus fy at 0, 1, we computed was 1/2, times y minus b, and b is 1. And there we have it. This is the equation for the tangent plane.